the next and final session of the morning is really special to us. Again, it's another professional that I've worked with before, or firm. We have Michael Clark, Associate Director of Thornton Tomasetti, for whom, or with whom I was very, very fringe involved, but nevertheless went and saw many times the Minnesota Vikings Stadium being built. They were the structural engineers for that, of course over the other side of the Atlantic, but a great firm of engineers, and Michael Clark is part of the facades engineering consultancy within that firm. And we have Andrea White, who's an independent fire engineer supporting designers and developers through her own consultancy, AW Fire Limited. She's an incorporated engineer via the IFE and a chartered building engineer via CABE and an IFE registered fire risk assessor. So we're going to dive in to this territory, which is what do we mean when we are talking about overcladding? What is the facade engineer's role in overcladding? Reasons for overcladding? Technical challenges associated, and then of course relevant changes to approved document B in the Building Safety Act. It's going to be a 5-minute opening presentation by each speaker, and then a 15-minute panel discussion and a 15-minute Q&A. So Michael and Andrea, welcome. And I don't know which of you is going to speak first. If somebody doesn't grab that button quickly, I shall nominate somebody, but over to you.
Thank you, Paul. I think it's noticeable that this session has been specific about overcladding, because it's often a topic that perhaps gets shunted to the side in comparison to new buildings and the complexities around that. And as facade engineers, we don't tend, or hadn't previously tended to be involved too much in overcladding projects, because they were tended to be regarded as a simple option, didn't need as much consultant or expertise input. But I think we're seeing nowadays that as the complexity of these buildings increases and the risks that have been associated with not addressing some of those challenges properly, there's a change in philosophy about getting additional expertise involved in these projects. I thought I'd start by offering an idea of what we consider overcladding to actually encompass. I think the first thoughts are those scenarios whereby you add you take an existing building and you add a new layer to the front of it. It might be a decorative skin or something to add additional insulation. But we also consider the scenarios whereby you strip back a building to an existing structure and add a new facade onto the top of that. The challenges are similar. There are differences, but you're still working with existing constraints, things that are unknown, it can be more challenging sometimes, I think, than starting from scratch on a new project. So, as I'm sure we will have a discussion later on in this session, there is an awful lot of development and change in the regulations that affect not just new buildings, but also any refurbishment and overcladding projects as well. And as facade engineers, we sort of take the role of trying to bridge the gap between the designers and those other consultants that are providing their performance parameters for the project. And we sort of try and develop those solutions that are both buildable and achieve all of those often competing performance criteria in a way that satisfies both the design intent, but also those who are going to be building and maintaining the building for years to come. So if we think about why overcladding might be considered as a suitable option, I think in the current climate, there has been a lot of discussion about whether we should be demolishing or even discarding existing building elements, both from a sustainability scenario, looking at embodied carbon, material waste, that sort of thing. We're certainly seeing a lot of clients and building owners at least examine the potential of reusing or renovating an existing facade rather than immediately looking at demolishing and starting from scratch. Perhaps one of the most obvious reasons for overcladding historically has been to improve the energy efficiency of older buildings. Facade systems that were installed 20, 30 years ago were not very energy efficient. They didn't have the drive that we have nowadays to keep temperatures warm in the winter and cool in the summer. So we've seen a lot of examples whereby there is a desire to add additional insulation onto the existing skin of a building. It can also be a cost-effective way of changing the aesthetic of a building. Again, some of these older structures may not be in keeping with what tenants or building owners want from their new building, or from their renovated building. So it can often be more cost-effective to add a layer to the front of the cladding than to replace it or knock the building down completely. And it may be the only option of allowing an existing building to function once its facade has reached the end of its service life. It may be that, particularly in the sort of the recladding world, there is nothing more that can be done for the cladding. It has reached the end of its usable life, but the structure beneath it may be perfectly serviceable and have decades more service life in it, and therefore just replacing the facade is a sensible option. Perhaps the scenario that we're encountering a little bit more recently is the example where buildings are being found to be unsafe. Their cladding doesn't meet existing or historic building regulations, is considered a fire risk or a safety risk for other reasons. And this necessitates some sort of intervention to either replace or repair or carry out other mitigation measures to ensure the safe continued occupancy of those building works. So when we look at all of those reasons why overcladding might be considered, and we can see that as a result of those discussions, it may often be considered the best option, we need to consider what technical challenges this brings to the design team as a whole. Obviously, the focus of this session is about fire. There are technical challenges that go beyond that, particularly when you're using an existing building to support or to replace and add something new. Can the structure support a new type of cladding? Can the existing cladding allow the addition of a second skin on the top of it? Perhaps the biggest challenge is the unknown of not quite knowing what has been built. You can see the outside, but only through surveying, invasive actions, or the actual removal of the cladding itself, where you really see what's under that outer skin. And assuming that all of this approach can work, we need to make sure that we're not adding additional problems that were never there in the first place, particularly interstitial condensation, drainage, durability of components, etc. But from a fire performance perspective, I think the critical technical challenge is understanding that the existing facade and the building as a whole will have been designed to have an integral fire strategy that encompasses all aspects of the building, including the cladding. And any changes to that facade, even though they may be considered fairly minor, can have a significant impact on how that strategy actually works. We've seen that the overcladding of existing facades with a new rain screen or a new insulated facade can fundamentally change how, in the unlikely event, hopefully, of fire, how the facade behaves. And it's not as simple as just making sure that the materials that you use in the design are meeting the relevant codes. It's about understanding that holistic function that it will have on an existing building.
Okay, Michael. Well, on that note of it's not as simple as, let's pause there and just have Andrea's opening remarks, and then we can get into some deep questions which interrogate that simplicity or not. Andrea.
Thank you. Yeah, so I undertake fire risk appraisals of external walls, which we call FREWs. I sign the EWS1 forms, which many lenders now require, and I also carry out expert witness work for the courts in relation to fire safety and external walls. So from my perspective, I think I really wanted to touch on 3 points. One was the upcoming changes to ADB and how those might affect external walls. The second point is some relevant points around the Building Safety Act. And then lastly, I wanted to mention a recent court case relating to external walls. So firstly, approved document B. As we've just heard, there are changes to both Volume 1 and Volume 2 of ADB, published in June and which come into effect on the 1st of December this year. With regards to cladding, particular relevance is that the 18-metre requirement for external surfaces and insulation, being of limited combustibility, now will apply to much lower buildings, so residential buildings that are over 11 metres to the top story rather than 18. And I would suggest from a firefighting perspective, this certainly seems like a sensible way forward. I understand that does create challenges when combined with a need to attain particular U values for thermal insulation. But I also want to mention that the definition of relevant buildings will also change under the changes to ADB, and relevant buildings will now include hotels, hostels, and boarding houses, which were previously excluded. So I think that's an important point to make. It's not just it won't any longer just be blocks of flats. Secondly, my point about the Building Safety Act, that received royal assent in April this year, and the bulk of the new obligations come into force over a year or 18 months hence. It certainly earns the title of being a weighty tome to digest. It's several hundred pages. But one thing that I think is particularly relevant is that from the 28th of June this year, the Act has enabled increased access to redress through the Defective Premises Act and Section 38 of the Building Act. And that means that private individuals now have the right to bring a claim for compensation for physical damage as a consequence of a breach of duty imposed by the building regulations. And also the Act extends limitation periods for claims relating to dwellings. So we go from 6 years to 15. And actually there's a limitation period of 30 years for claims arising prior to June this year. Now, the legal test under the Defective Premises Act is whether a building is unfit for habitation. And at first glance, that sounds like quite a high bar to meet. But I would suggest that case law actually says otherwise. For example, not meeting the building regulations could constitute a premises being deemed as unfit for habitation. And then lastly, I wanted to touch on the recent legal court case of Martlet Homes versus Mullally. Now, this case relates to 5 tower blocks in Gosport in Hampshire. They were refurbished by Mullally and Co Limited in the mid-2000s. And that work included the installation of external wall insulation, rendered cladding. Now, following the Grenfell tragedy, fire safety defects were found in all 5 blocks in relation to the external walls. And Martlet was successful in being awarded the full replacement costs and the costs of a waking watch from Mullally. Now, the part of that case that I think is particularly interesting is that it established that reasonable skill and care is a separate obligation to the strict obligation of compliance with building regulations. So what does that mean? Well, it means that not only does reasonable skill and care have to be shown, but separately it needs to be demonstrated that the building was designed and built in compliance with building regulations. An individual cannot therefore rely on the argument that a reasonably skilled individual wouldn't have a sufficient understanding of the building regulations. And for me, then, that raises the question of how far an individual's competence should extend. Is it reasonable to expect a designer to have a sufficient grasp of Regulation B, for example? Those are my initial thoughts, and I look forward to having a discussion now. Thank you.
Good. Well, what a start, and what a wrap up there with the Mullally case, which we'll come back to, I'm sure, in a moment. Faye Ferguson asks, facade engineers, should you be leading the scoping of fire stopping and cavity barrier design intent in the early design stages, including on those that you are overcladding where there is an existing facade. And before, and I'll place that with you, Michael, but before you start on that, can you wrap into that answer? When should an architect or a client appoint a facades engineer? And to understand that better, can you explain what's the scope of service you offer? Do you get involved at the concept stage? Do you get involved at design development up to employers' requirements being prepared? Are you involved in production information post what is normally novation for the designer? And do you get involved in site inspection?
I think the short answer is yes to all of those. I think it normally falls into two categories. We're either engaged at the beginning of a project as part of the design team. We can be engaged once the building has gone on site to assist the client with inspections, or across the full scope. I think what we're finding in the current climate is we can add more value the earlier we're brought into a project, because we're finding that the development of facade design to accommodate all of these competing criteria now, particularly the fire, but also the thermal performance, needs to happen much earlier, because in order to comply with all of the regulations and guidance, we really need to have an input right at the beginning of a project, before materials are selected, before cladding zones are defined, before net areas are agreed. The later we get involved, the less we can do to improve all of those things.
Okay, I got that bit, but then somebody a little old-fashioned like me on this issue, or perhaps who's been around the block a few times, would say, yeah, but that's what we used to do anyway. It's inconceivable to me that you could develop the concept of a building and not think it through in a holistic sense. But this takes us straight into the same question really for Andrea, but also picking up on another point, which is Andrew Fern. I'll read it all and then phrase the question. Some older residential developments that were previously passed under outdated regulations that are then retrofitted with a new cladding system present inherent issues that go beyond cladding alone. This means the means of escape and fire exit strategies, stay put or otherwise, may now be considered unsuitable under new regulations. Should the recladding of a project therefore trigger a fresh look at the whole job? Now, that we've got both of you on here. Here we have a fire consultant. You must think holistically about everything from means of escape through to warning systems, signage, the whole caboodle, Andrea. And we have Michael with a focus on that external wall, which I'd just like to throw in that great quote by the president of the RIBA back in 1971. Buildings should be about long life, loose fit and low energy. So there's the consideration. By golly, in 1971, that's a good 50 years ago, he was talking about long life, loose fit, low energy. But so we're going to have lots of substantial reworking of buildings. Andrea, how do you make sure that the design team, with the architect presumably coordinating the design, have a proper balance of inputs, so that when they're taking expert opinion from somebody like Michael here, they're still thinking out the whole project in terms of spatial organisation?
Yeah, I mean, it's frustrating from my point of view, and I'm really pleased to see the recent changes in terms of things like fire strategies, fire statements and planning fire safety strategies. So bringing those in at sort of REBA stage 0, I think, is a really good move, because it involves a fire professional at a stage like Michael said earlier, that at a stage when changes can be made. I think the frustration as a fire engineer is if you're instructed at REBA stage 4, then often you're told, well, actually there's very little that we can do to change now. We're tweaking rather than having any meaningful difference. So for me, I would like to see competent input throughout all the REBA stages, and I'm not terribly worried who that comes from, but I think my experience says that that's probably not the case. And if it's, we're designing buildings now that are much more complicated in terms of everything, in terms of materials that we use, in terms of how we occupy those buildings, and is it acceptable now? Is it reasonable to expect one person to have a sufficient level of fire safety knowledge as well as everything else that they might do? So for me, I question why we aren't bringing in a fire engineer at those earlier stages. And my hope is that the fire statements and the planning fire safety strategies are an attempt to try and, make that input, that technical, competent input, part of the process throughout all the REBA stages.
I think one thing that is absolutely the case, and this perhaps comes back to you, Michael, is that we are getting materials and components for our buildings, particularly the external envelope, that are less tolerant of late engagement by the people who work with them. I'll put that into better English. If you were putting a roof on a building and it was lead, you've got a lead worker, and lead can be worked on site. It's a craftsman's task. Stone, brickwork, these are all involving the skill of very, very able people who can use their tools to work these materials into plastering, decorated plastering, and on we go, render work. We're now getting buildings put together where even the construction might be modular construction, for example, in hotels. You've got modular construction, which is got a structural role, you've got cladding systems, you've got bathroom pods going in and out. The drive is consistently for more and more to be done in a factory somewhere, even completing full flat pack products that get opened up on site or delivered to site with their volume intact. But the work on site is very much more difficult because the materials are intolerant. If you've got aluminium panel, what can you do with that when it's on site? Cut and formed and not quite the right shape. So it's very demanding of us. Now, where I wanted to go with that question is that surely requires much more precision much earlier in the design drawings and specification and the fabrication drawings. But it also requires a much better understanding by people who are receiving these sophisticated products and systems from somewhere else and then assembling them on site. Because if you haven't got the skills on site, the sophistication of the product can be very much compromised by poor installation and workmanship.
Yes, I think one benefit that prefabrication has brought to us is the improvement in quality, and constructing things in factory conditions means that we get much higher quality in a lot of the components, and we can also have much better quality control and recording procedures that allow us to understand exactly what has been done and record it in a way that we know what is being covered up. I think the challenge becomes the coordination between those packages on site. Because if you've got someone bringing in, as you say, a prefabricated cladding unit, and they're interfacing with someone who's doing a prefabricated MEP component, and then you've got a structure that's being done by someone else, who is responsible for all of those interfaces? And that doesn't just encompass the fire, it's the waterproofing, the thermal performance, etc. But particularly for the fire, because that fire strategy for the external envelope is holistic across the whole project, it encompasses all of those packages that are coming together. And understanding how, particularly with materials, how do those materials interact with one another in the event of fire or in prevention of fire? Where do we need to put fire stops, cavity barriers, other means of making sure that building does perform well in the event that there is a fire is a challenge, and it needs not just the specialist contractors involved, it needs the main contractors and those responsible for inspections and signing off the works to fully understand what is required of everyone involved.
Andrea, facade and building, if we think of facade as being the obvious outside of the building, it could be an overcladding, that is something stuck on an existing cladding, or it could be strip the existing cladding off, back to the bare frame of the building and then overclad it again. But when the facade meets the building, where are the pinch points and the big issues to look at and be warned about? And I'm thinking here, I suppose, about compartmentation and compartmentation strategies against stay put or escape, and the relationship of that to what an external cladding is doing.
Yeah, so, I mean, for me, I think it would be safe to say that the real issue is the fact that this country uses stay put as an evacuation strategy. There's not many countries that do that. And if we're going to do that, then, as you say, compartmentation is really important, because we're only evacuating the people in the flat of origin, the flat that's involved in potentially a fire. Everybody else is staying put. To answer your question, I spend most of my time looking at photographs or on a site looking at cladding that has been partially removed to look at, what's there and how it was installed and the quality of insulation. So for me, that there's really four things, I think. One is poor workmanship at install. It is poor. It's disappointingly poor, I would say, in most situations. Another one is incorrect substitution. So the amount of buildings that I see that are over 18 metres to the top story and they've got combustible insulation. Now, I totally understand that at some point somebody did design it potentially with A2 or better insulation, and then someone couldn't get hold of that and thought that the U values were the same and therefore it would be okay, and didn't perhaps consider the fire aspects. So that's another issue that I see. Another issue I see is incorrect design. So I can recall a building where the owner had very carefully ensured that the new block of flats was clad with A2 or better. It wasn't even 18 metres. He didn't need to do it, but he wanted to be able to sell his flats with the appropriate EWS classification, EWS 1. And when I looked at the photographs, after it had all been put together, I realised that the design used open state cavity barriers in the vertical orientation. Now that's not a tested solution. So unfortunately, despite everybody's best efforts, it was designed incorrectly. And I couldn't give it an A in terms of what he was looking for an EWS 1
Can you explain for anybody who doesn't get that, what is open state in the vertical position? I happen to know, but it needs explaining.
Yeah, so cavity barriers we would find in a wall, in an external wall, either horizontally or vertically. And if you need to ventilate that cavity in the wall, then you can use open state horizontal cavity barriers, which means that they have an intumescent face to them, and
bingo, the way they go.
When they're subject to large amounts of heat, they will intumesce and close that cavity. But actually, in the vertical orientation, you can't use intumescent cavity barriers, open state cavity barriers. You need to use full fill, which actually permanently fully fill the cavity.
This is going to take us to the heart of an issue, because I have even seen open state used the wrong way round with the intumescent against the building. I mean, astonishing. But we got here, Mark Taylor says, somebody said terrific question, that's nice of them, but Mark Taylor, you're looking for an automobile level of assembly on a cold, wet Thursday with a guy on the minimum wage. guys or women on minimum wage, on a rainy site. And could Andrea comment, says Sophia Roycroft, on the idea of proportionate response in respect of overcladding, recladding buildings where issues have been picked up? Is she seeing this changing the way contractors or developers are addressing problem buildings, and clarify whether the changes to the regs will apply retrospectively to the existing buildings where issues have been picked up in the ESWI surveys? Now, before we dive into that, I got a sense that this morning is bringing us hard round to the issue of the quality of work on site and the quality of inspection of that work on site. I'm not saying there aren't problems elsewhere, but at the end of the day, if everything else is done right, it's useless if that quality isn't right on site. Back to the automobile point, and it's a rainy day. And my view is that we cannot have, architects cannot have enough help in this territory. The old days we used to have clerk of works, but they tend not to have that level of engagement with site inspection anymore. It's more a tick box process, and I'd like to see clerks of works who are fully understanding of the trades and come off a real experience of building background and can go and look on site. So can we just look at site in relation to the question that just got asked by Sophie? And both of you, it would seem to me that buildings can only be better if we have major facades, if we have both a fire consultant and a facades engineer assisting with inspection of those that are responsible for installing. Surely that's got to be right. Tell me why I'm wrong.
I don't think it necessarily has to be a fire consultant. I mean, if you want to use a fire consultant, then, I'm very happy to look at standards of construction, but I can't be there 24/7. And I remember clerks of works when they existed at the beginning of my career. And, I genuinely struggle to understand how their demise, and particularly given how much more complicated we've decided to move towards in terms of materials or solutions to buildings. I think, the gap has widened between oversight and technical competence. And I think that's a real problem, because even if you do design it competently, then if it's not put together correctly, if it's put together with very poor standards of workmanship, then it doesn't matter how good the design is. It becomes fairly irrelevant.
Well, let's bring Michael in then, because Michael, this brings us back to the very heart of an issue. If we are going to rely on site checking of work done by others, who's going to do the checking? That resident site architect, resident clerk of works, resident facades engineer? There's the one question. But the second part that comes from Andrea's contribution there is, should we have to do so much checking? Because if the culture of the firm doing the installation is correct, and I've seen situations where you've got a design build contractor who's subcontracted to a specialist subcontractor for cladding, who subcontracted the design work that they do, which is actually fabrication drawings, to another firm, and they also subcontract the installation of the work. So they're basically a mini main contractor for the wall now. They subcontract the work to another firm who subcontract it to the guys who actually go and do it. How do we get this checking? And is it going to come off the floor? The culture of those doing it is sufficiently professional that they know what they're doing, why they're doing it, and why it's going to be right.
Yeah, I think that's the key, isn't it? It's the making sure that everyone on site understands their responsibilities and improving that, both the competency and the checking. I think it's worth noting that we work with some very good contractors who do take this very seriously, and so it's not a wholesale industry issue. We see that there are contractors now who are taking complete photographic records of all the works that are being closed up around fire, both for their own kind of peace of mind and to demonstrate to clients, tenants, whoever they might need to in the future, that what you can't see is actually there. It's all compliant.
And I'm
but
so
I think,
glad you said that, because I have worked with many, many very fine contractors who take these issues so seriously, and that was before the terrible night of Grenfell. I've been working with contractors who are deeply committed and responsible. So I'm glad you said that. But we still go back to the point that Mark Taylor made. I'm looking across at it. You're looking for an automobile level of assembly on a cold, wet Thursday with a guy on a minimum wage. So are we actually saying, perhaps, and I hope I can encourage you to say this, but you might not agree with me, that we ought to have qualifications for people who are installing this stuff? You can't just arrive and be doing work of this kind of importance, surely. We must have better training, and people who are installing must understand the systems that they're installing from the point of view both of the original design team, facade engineer, architect, structural engineer, but also from the point of view of the manufacturers.
Yeah, I think that's right. And understanding how all these components need to come together for a specific building, that's the key. There are no sort of generic solutions anymore, I think. Every building has its own strategy for both the cladding design and the fire strategy. So what you did on...
And you're going to remind us,
you'll
remind us, no doubt, that every building is not only specific, but every building's a prototype, which is our other problem.
Absolutely.
Andrea?
Yeah, I've started to get involved with the cladding sector, who are looking at a joint competence initiative, and they've been very clear and said, we cannot demonstrate our competence, and the Building Safety Act requires us as professionals to be able to do that. How can you demonstrate your competence? And I think it's a very good point, and they're now, seriously looking at how different professions within the cladding sector can demonstrate that competence. And one of the points that they are looking at is training for on-site staff, installation individuals, and it's interesting, isn't it, that it's taken the Building Safety Act to get to that point.
Well, we get the comments rolling in. I'm looking across. Mark Taylor again says, thank you. So I thank you both. A very good point, well made. We need training for site workers, which takes us back to apprenticeships and all the rest of it, which I suppose takes us to an even bigger conversation, which is having a pride in making and doing things. I was listening to a TV program the other day where a woman who was running a factory somewhere up in the north of England, I've forgotten what it made now, but she was saying how important it is to get young people who come in to work in the factory who have an interest in what they're doing and are seen to be involved in a respectful activity. Now I've got to be careful here because this opens up a Pandora's box of things, but she said she had worked in production all her life and had a huge pride in it. And I think that we do need to reset the bar in this country. We need a better respect for those people who have the onerous task of putting things together, often in very difficult circumstances. I'm thinking of speed of time or dangerous position to be working high on a building, or we've seen it with the oil rigs, but buildings can be very dangerous in difficult places. And I think we need a changed mindset in terms of the respect for those people who do such important work. And I think when that respect is enriched, we're going to get better performance as well. Look, I've taken up the last 35 seconds, 40 seconds, and it's gone to zero. It's lunchtime. So can I thank you both very, very much indeed for rounding off this morning. It's been a full and good morning, but it was really good to get into this territory with both of you. And I look forward to getting back together with all the delegates who are no doubt going to rush off for their lunch or that midnight cup of cocoa if they're down in Australia. And I hope Australia is going to have the energy to stay up with us, the delegates down there, as we go off into the early hours of their morning with the next sessions after lunch.